So thank you so much for coming. My name is Jesus Aguilar. I'm an engineer at Microsoft, commercial software engineer. I'm here to talk about Kubernetes on Azure. I'm also going to step back a little bit and talk about what are we doing in container space in general. I think there's a lot of exciting announcements that just happened recently at our Build conference. But in addition, I kind of step back a little bit and give you the strategy of how we're thinking about this. And that would be an introduction to what Donald is going to be doing, which is demonstrating a deployment of Couchbase on Kubernetes, Azure Container Services. So I think it's a super exciting thing. It's, we're super passionate about what we're doing in the container space. So let's get started. Just to get the level of understanding about the room, anybody using Azure nowadays? Okay. Is anybody running containers in production? Yeah, so the number of hands kind of is representative of what we're seeing. We are past the idea of containers not being something that people will not use in production, right? We're seeing nowadays that containers are becoming ubiquitous. Containers is the new wave of virtualization, and we are 100% on board in that idea, right? And the way we're doing that internally within Microsoft is we're embracing that in two forms. We're providing platforms so people can build on it. We want to make sure that those platforms are open, go according to what the community is going. We're not necessarily, reinventing wheels where we don't need to. We're providing incremental innovation on the things that are already built, and we know it works. So that's our journey, right? And in addition to that, we're also embracing container technology internally. A lot of our products now behind the scenes actually run on containers, and we're going to see more of that going forward, right? And fundamentally, our North Star when it comes to containers is we want to democratize the use of containers. We want to take it from a development-oriented type of idea and make it the next wave of virtualization, right? Where people can embrace and get value right away as they deliver solutions. So when it comes to the ecosystem of Azure and how we're tackling containers in general, this is a little bit of an eye chart, but I think it's kind of revealing where we're going with this, right? First off, on the I guess on the right side, in the middle, you see some of our key offerings that actually can allow you to run containers. And those offerings, for the most part, you can think of them as orchestrators, right? So we have a first-party offering called Azure Container Services, or AKS. And that's something that we just are running, super excited about it. I'm going to talk about it in a second. But, think of it as Kubernetes as a service, right? And then we have our own orchestrator that grew from a lot of internal projects called Service Fabric, which also allows you to do orchestration or containers in general, right? But in addition to that, we have several other components that are super important to the whole ecosystem on containers, right? Because it's not only the orchestration piece, it's also the ability to connect containers to cloud services that might be running on Azure or might be running elsewhere. And for that, we have the service broker implementation of Azure, which I'm going to talk about it too. And in order to manage containers, you have to pay. You need to put them in a place where they're secure and that you can access them as part of your deployment, as part of what you're trying to do. And for that, we have Azure Container Services, which is a first-party service. And all that is running on the same platform, infrastructure as a service platform of Azure. The same semantics that you use to deploy anything on Azure basically are consistent across all those offerings, right? So let's double-click on Azure Container Services. What is it? What is Azure Container Services? It's also known as AKS, and AKS stands for Azure Kubernetes Service. We recently renamed it from AKS to Azure Container Services. We're not very good at naming when it comes to some of our offerings, to be frank. One warning, you will see something else called ACS, or Azure Container Services. It's a V1 version. That's something completely different. At the very least, the documentation now of AKS has Azure Container Services and has the in parentheses AKS, so you know that you're targeting the right version, right? So what is it? The best way to describe it is Kubernetes as a service. Right? It's Kubernetes. We didn't change anything about Kubernetes. 100% Kubernetes. You can run Kubernetes in your own cluster. You can run Kubernetes that workload in Kubernetes as a service. So what is the value proposition that we do? Well, first of all, the master nodes, we manage those. And we don't charge you for those. what gets deployed under your control are the nodes, but we manage those as well, right? So when you think about a cluster of Kubernetes, if you have 4 nodes and 2 master nodes, then you only pay for the 4 nodes that actually are doing the work, right? And you can scale those in and out as needed, and you can interact with them as any other Kubernetes cluster. In addition to that, we manage the security aspects of the operating system. So when a new release comes in, security patch, we patch your nodes as well. We patch the master nodes, of course, and we manage all that, right? So the best way to take a look at it, the best way to understand, I think, is to see a demo. So I'm going to try to do that. First of all, a warning sign. This is a live demo that depends on the internet. And I didn't do a video. So wish me luck. So the first thing that I want to show you is how do you deploy the Kubernetes cluster on Azure. It's very simple. You actually, can you guys see this? Use the command line. You say AZ, which is the entry point for a command line. Create a couch demo. Somebody's pinging me. Hold on. So what I was, sorry guys. You say create a cluster with the name Couch Demo 3 in a resource group called AKS Couch. A resource group on Azure is a management construct, right? So you have to use it elsewhere. It's how you can group resources within the deployment, right? And then you can specify the number of nodes that you want. So once you run this, the deployment is going to happen. It's going to take some time. So instead of showing you, a black screen, what I'm going to do is going to take you to an existing deployment of the same thing. Hopefully you can see it. And show you what it looks like on Azure. This is the Azure portal. So what I'm showing to you is a deployment that I did earlier of exactly the same command, which basically is a cluster of Kubernetes with 2 nodes. And what you will see here is that you get the access to, the IP address, the version. You can upgrade Kubernetes if you want to. By default, this is an old deployment, so I have 1.7, but if you want to upgrade to any of these versions, automatically the platform will do it for you. If you want to scale the underlying infrastructure, the nodes where all your pods are running, you can certainly do it here with a click. And you can scale as long as you need it, right? And then the other thing that you can do is you can start looking at the health of the system in a very comprehensive way. So for instance, you can get metrics of what's happened to your pods by state, by memory, whatever metric you think is relevant for your cluster, you can see it. You can see the health of every particular node and what has been deployed in that particular node at a very granular level. All this information is logged into our analytics platform, but it's using the platform of Azure to surface this information in an easy way for you, right? And once you have the cluster, this is no different than any other cluster in Kubernetes. And to demonstrate that, let me deploy an app. And the app is going to be deployed here. So what we're going to do is I have an alias for kube control, which is kube create -f. There you go. So what I'm deploying here is a very simple Go-based web app that is just going to be deployed in the cluster. If I do the same thing to just get the status of the service, you will see that now I have 2 deployments happening here, right? The first one that is something that I deployed earlier before this, and you see that the one that I just deployed right here, the external IP address is getting populated. It will take a couple of minutes, so I'm not going to make you wait. And instead of that, I'm just going to show you what I have deployed already with this external IP address. Just going to click on it, and it's a simple echo app. So whatever I get in the URL, I'm going to get it back. Here you go, right? So I put hello NYC2, and this is running live in a Kubernetes cluster on Azure, right? And this is a Go app, right? So that's exciting. I guess I'm a developer. I think it's exciting. So so the next thing that I want to show you is let's assume that you want to use the dashboard, right? The Kubernetes dashboard. So dashboard is a very easy way to do deployments, and you're not familiar with the CLI or to understand what's happening with your cluster. Well, the way you do it is with that simple command that I just show you over there, AKS browse. You specify your cluster, you specify your resource group, and then what happens behind the scenes is that a tunnel is created, and this tunnel is created into your cluster, and then you can browse your cluster directly, right? So I'm connected to a local endpoint here. Hopefully the connectivity will work here. Let me do it again. Again, live demos. I'm living on the edge. Here you go. It's handling the connection. I want to show you that, hopefully it's going to show the app that I just deployed in a second, or 2 seconds, or 3 seconds. Okay, so, it'll all come back, right? The connectivity is happening. All right. Timeout. Yeah, I was pushing my luck with this, right? Yeah, I was pushing my luck. Okay, so, but the point is, you get a tunnel directly back to it. Everything that I just show you, you can do it through the CLI. So it's straightforward, super easy, and we're super excited about this. So let me tell you about another really cool piece of technology that we have called Azure Container Instances. Azure Container Instances, the best way to think about it is a container that lives in a cluster that we control, right? So what's important about that container is that unlike containers that you create on your VM or in a physical machine, those are hypervisor containers. What that means is the kernel is not shared across the containers, so they are more secure, right? And these containers, we only charge you for the compute aspect of the container. So you have a bursty workload that you just want to spin up a bunch of things as a result of millions of sensors sending data over. Then you can process that, and then it will tear down, and we only charge you for the compute around that container in particular, right? And you can use that to also scale your AKS cluster with something that we call the ACI connector, which basically allows you to connect containers that are container instances as if they were containers or pods, right, in your cluster, right? So you can have a central, you can have an architecture where you have a central a main cluster with a certain amount of pods deployed to it that is your stable system, and then you want to scale that out because it's a bursting workload. You can use this architecture to spin up as many containers as you need and then bring it down in a very cost-effective way. So that's kind of a visualization of that. So let me show you now, what that looks like, behind the scenes. And again, taking the risk. What I'm going to do here is I'm going to go to a console here. And what I'm going to do is actually going to modify some code. So this is the Go app that I just showed you. I can barely see it, but basically, it says hello in red. So instead of doing that, I'm going to say hello NYC. And this is Go code. It's living in a VM. And what I'm going to do now, I'm going to create an image out of this code, and I'm going to push it to my ACR, my container registry that I already set up. That is private. It's mine. Nobody else has access to it, right? So by the way, what you're looking at is a VM running on Azure. So I'm SSH into it. So it's, talk about risk here. So Go app demo. That's it. Good. So I created, compiled the code, did everything that it was needed to do. So now let me do a Docker push of what I just built. Which is given to code Azure CR.io, go up. You see something wrong, let me know, okay? Please help me out here. Sorry? Yes, I can make it bigger. So let me show you what I did. So it's Docker push, nothing out of the ordinary. What you're seeing is I'm prefixing my image that I just created with the name of my registry. So let's do that. That's been pushed. And now what I need to do is to create an instance of this, right? And the command to create an instance of this is right here. So I'm going to walk you through that. Oops. So a couple of things. So I'm doing AZ container create, straightforward. And I am asking the system to create a container called my demo1. I'm going to change that name. And I want to use a public IP address, right? So I can access it remotely. And I just specify the image that I just pushed, and I specify the port that I want to be open, right? So I'm going to change that name here. Are you recording this? Because I just have my password here, out in the public, so you can see it, I'm sorry. I'm going to change it. So right now, as soon as I finish, I'm going to have like 1,000 images then getting pushed there. Who knows what is going to happen? Anyway, So what you saw is a deployment of a container. Notice how fast it happened, right? Because that's the value proposition of containers. They spin up really fast, and now that is running. What is taking some time right now is going to be the IP address, but let me show you an instance that I created before, so you can see the code change, if this thing allows me to do it. So this is the one that I used. Did I call it my demo 2? Yes, I think so. So if I go here, change the IP address, what I just had before. Now instead of saying hello France, it should say hello New York. There it is, right? So I just deployed the container instance, spin up very quickly, deploy the code that I did, and it's there, right? And it's using containers, Kubernetes, as easy as it could get. Now, so far we talked about the runtime environment. We talked about, Azure Kubernetes Services, the ability to spin up instances with Azure Container Instances. We talked about, ACR as the place where you can persist images. But what about automation, right? So all the automation tools that are important or well known in the industry around Kubernetes, we support those. As a matter of fact, Draft, if you guys haven't used Draft, it's a project that started from Dias, and Dias is a company that recently we acquired Microsoft, right? So we're 100% committed to Kubernetes. We continue to be one of the main contributors to the Kubernetes project itself in different forms, and the automation tools that we're building around Draft certainly confirm that value. But the point there is, if you want to do Kubernetes in Azure, it shouldn't be different than doing Kubernetes elsewhere. And as a matter of fact, we should provide. Our goal is to provide more value on top of what you already love about Kubernetes. And finally, I'm going to talk about the Azure Service Broker for Azure. So the Azure Service Broker for Azure is based out of an open API called the Open Service Broker API, which is a specification that allows an abstraction on top of services that run on cloud providers. And what that allows you to do is to combine those services as part of your deployment within Kubernetes. So you can have a deployment where you can have your web tier or your web API tier and Kubernetes, and then as part of the deployment, you can also specify a backend that you want that maybe is a platform as a service offering from Azure or some other platform that you need, right? And that's a very active project. Again, it's an open source project, and we're committed to continue to maintain it over time. So as a quick summary before we go into the demo of deploying Couchbase on AKS, just a quick summary of the things that we covered today. Very quickly, I know it was very quickly. I'm rushing a little bit, but I just want to make sure that you guys see the demo. We talk about the container technology, where we're going with this. The bottom line there is we want to democratize containers. We want to make sure that if you are comfortable with the tool and you wanna look at Azure, that experience is going to be even better. We talked about the two main offerings around containers that we have: Azure Container Services and Azure Container Instances. And we talked about the container registry as the secure place where to store images for your deployment. And we talk about the orchestration and release tools as a whole. Happy to answer any questions that you might have. But with that said, let me introduce you to Donald from Couchbase. He's going to walk you through a demo of Couchbase on AKS. Thank you.
Hello, everyone. I am even more nervous than Jesus because I have no slides and I'm going completely live with a crappy internet connection and in the cloud. Okay.
They're going to change my password right now.
It's not working. Okay, there we go. Sort of. Let's see. Okay, there we go. Okay, hi guys. Oh, you can't see that. Let me know when you can see this reasonably well. Yeah? Okay, I'm Donald Scott. I'm a solutions engineer with Couchbase. I give demos for a living, so I'm going to give you a demo today. I'm a fill-in. My colleague is in London, and he could not be here. So I'm not the expert on Azure, so we'll defer to Jesus on any sticky Azure-related questions, and we'll go into this. So my goal here is to demonstrate to you the Couchbase operator inside of Kubernetes. Who knows what that means or if that makes any sense to anyone? Yeah. Anyone go to the operator talk earlier today? Okay. Okay. Who's familiar with Kubernetes in general? Who does not know what Kubernetes is? No. Well, I wasn't paying attention because I was trying to get my demo to work. So. Okay, so yeah, everybody knows what Kubernetes is, what the goal is of it. You know what the Couchbase operator is. Tell me what that is, what that means.
The manager?
Yeah, so it's kind of a manager. So the reason it's important, if you didn't go to the talk earlier today, is there's various ways to integrate with Kubernetes. It's particularly challenging for, and I'm stepping a little bit out of my element here, but it's particularly challenging for stateful applications like databases, right? So other database solutions have implemented or tried to integrate with Kubernetes. I won't name any. We are one of the few NoSQL vendors that actually has an organizationally supported integration with Kubernetes. Other vendors have relied on support of the community to build their integrations. And we had an evolutionary journey as well to get this integration correct, right? So there's various patterns, one of which is the sidecar pattern using stateful sets, where you have your Couchbase cluster pods, that's a Kubernetes term, and you have a separate pod that's trying to manage the organization of the cluster because those pods don't know anything about each other. And you can imagine how much of a mess and nightmare that is and was for us, right? So, but now we've taken a different path and we've kind of integrated more tightly and more natively with Kubernetes itself by using its operator API, right? And so we're hooked into the overall Kubernetes operator or controller, whatever you want to call it, they call it an operator. And so now all the pods that host Couchbase can be aware of one another, right? And so all the administrative tasks that you would ordinarily do as a Couchbase administrator, or many of them, have been taken care of in the logic of this operator. So scaling up the cluster, failing over down nodes, rebalancing the cluster, right? And so you can imagine what that means for you as developers or administrators. It means all that stuff you don't have to be concerned with anymore. You don't have to know the details of how to manage a Couchbase cluster even, in depth, because the operator will do it for you. So my goal is to demonstrate to you that actually works, okay? And we're going to do it in AKS because we love Microsoft and they're great partners of ours, okay? So what I have up here now are a few commands to get a simple deployment of Couchbase Operator inside of Kubernetes. I want to kind of walk you through what the commands mean. I didn't want to run them live because I don't think that would have worked out well. So I have a cluster deployed already, and we'll do most of the demo with that. But I kind of want to walk you through the instructions first. So the very first thing you have to do, if you want to do this in a scripted fashion, you could do it through Azure's dashboard online. But if you want to script it, you got to download their command line tool. It's called AZ, right? So I've got it downloaded, and the very first thing you would do is log in using your Azure credentials. I've already done that, right? The second thing you do is you create a resource group. In Azure, a resource group is sort of a container for various resources that are related to one another. And I'll show you kind of what that looks like if you haven't seen it before. So this is the Azure dashboard, if you've never seen it before. And so this is the landing page. If I go to resource groups, okay, and feel free to stop me if you have any questions about anything. If I go to resource groups, I have a couple of resources groups created here, two of which are related to this talk. The first is called My Resource Group, and that's the one that hosts the Kubernetes cluster that I'm going to demo with, right? So if I go into it, I can see all the associated resources, and currently I'm running one service, which is a Kubernetes service, and it's called My AKS cluster, right? So that hosts all the resources related to the Kubernetes cluster that I have running. I can go to all resources here and kind of get a look at all the resources that are the constituent parts of that resource group, right? So if you look at here, I've got various virtual machines, right, that are running my Kubernetes cluster, right? And inside my Kubernetes cluster, I have pods that are running Couchbase, right? So I've got disk, I've got routes, and I've got virtual machines, all the things that are the constituent parts of my resource group, right? So that's a resource group in Azure. So I create my resource group first, right? So I've got one called My Resource Group. I choose the region in Azure that I want to deploy it in. I'm doing it in the Eastern US region of Azure, okay? And then the second step here is I want to create a Kubernetes cluster inside that resource group. So the second command here, AKS create, does that, right? Okay. Then I need to install the Kubernetes command line tool. This command does that. And then I need to do this get credentials command on my resource group. What it does is it allows me to, it gives me kind of a local context with which I can connect to this particular resource group from my laptop, right? It gives me the credential file. It stores it in this file down here. Okay. Then once I've done all that, it takes a bit of time, but I've already done it, then I can start running these Kubernetes commands, right? So I'm connected to my resource group in AKS because I downloaded the credentials, and now I can start doing some stuff. So if I run this command, get nodes, it'll show me all the nodes that are currently part of my Kubernetes cluster. So I have 5 pods here, okay? So the next step is to actually deploy the Couchbase operator, okay, inside of the Kubernetes cluster that I created inside of that resource group, right? And so this file is hosted on AWS. No offense, Jesus. But this file is currently happens to be hosted on AWS. So I can take a look at you can take a look at it. It's just some parameters for defining the for pulling the operator in and some ports and things of that nature. So I can look at it really quickly. It's YAML. There's not too much is interesting in that file right now. So that deploys the operator, the Couchbase operator, into my Kubernetes cluster, which runs on a separate pod itself. Okay. And then the second step is the fun part where I actually create my Couchbase cluster, okay? And so that's yet another YAML file, also hosted on S3 and AWS. So if I look at that one, then there's some interesting things in here. So this is how we manage the shape and size of our cluster, of our Couchbase cluster. So everything in here, so I give a name to the cluster, some of the Couchbase configuration parameters, so these are kind of set it and forget it, unless you have reason to change them. So memory allocated to each Couchbase service, and by now, you guys have been here all day, you know that Couchbase has a service-oriented architecture, so we run various services. These are the memory allocations, the RAM allocations for each of those services, okay? And then I define some buckets. Buckets are like databases in Couchbase and a RDBMS, okay? Etc. Right? So the most important part here is perhaps the number of nodes in the cluster. So in my cluster, I initially am creating a Couchbase cluster inside of Kubernetes that is going to be hosted on 3 pods. So I'll have 3 nodes, right? In addition to that, the operator itself is an additional pod. And so I'm going to run all the services, all the Couchbase services on this, on each node in this cluster. By now, you guys also are aware of a feature that we call multi-dimensional scalability, meaning I can either run all the services on all nodes. You probably want to do that for testing. You don't want to do that in prod generally. Or I can split these services onto different nodes in the cluster. And so this file allows you to define that structure and to modify it, right? As you want to scale up and scale down the cluster with Kubernetes.
How
Yep.
do you define that?
How would I define an MDS sort of structure, a multi-dimensionally scalable structure? I don't know. I will get back to you on that, or I can get back to you on that. I'm sure you just changed the YAML file. I'm not sure how, but I'm sure it's in our documentation somewhere. But the simplest fact, or the simplest way here, or what I'm going to do for this demo is define all the services on all the nodes, okay? And then pass to the data and pass to the index on each of the nodes, okay? All right, so I've done that already, and I'll give you a little bit of a look at what that looks like. Okay, and so this is running inside of AKS, right? And so in order for me to take a look at it, I've got to do some port forwarding and things of that nature, right? So I run this command to forward the port of one of the nodes of my cluster to my local machine, right? And so if I look at the pods again, right? Oh, so that was an interesting command that I didn't show you. So I actually ran earlier, I ran get nodes. And so this actually shows me all the nodes that are running currently in my Kubernetes cluster, right? So obviously when you spin up Kubernetes, it's not running all Couchbase. It's running, you could be running tons of things, right? So the get nodes command shows me all the Kubernetes nodes, and the get pods command shows me the current pods that I'm running for this Couchbase cluster, right? So I've got 3 nodes in my Couchbase cluster. They all have names, right? And so plus the operator, which is running in a different pod. Now I'm going to basically forward the ports for one of those nodes so that I can connect to the cluster, and that's what this command here does, right? So I'm forwarding port 8091 to my local machine. That is the port by which you access the Couchbase dashboard, right? Okay, so go to localhost 8091, which is being routed out into the cloud, right, to the VM that's running this particular Couchbase node, right? And you can see, just like I said, just like my deployment, right, file set, I've got 3 nodes, right, and they're all running all the services, right, okay? Okay, so not terribly interesting yet, but that's how we get Couchbase cluster deployed in Kubernetes, right? Okay, another thing I can do is I can get a look at the Kubernetes dashboard itself if I want to look at that in a visual sort of way. So there's this AKS browse command, which will open up a browser tab to the Kubernetes dashboard. And there are various ways of doing this. This is the one that I found most convenient, being a newbie to AKS and Kubernetes. But yeah, if I run that command, it'll open up a browser tab, and let me make sure that it's still running because it times out. Yes, it did. Okay. So I'll run that again, and it will open up a dashboard to the Kubernetes dashboard running inside AKS, okay, on the cluster that we deployed. And so the most interesting things here for us are the deployments, right? So I deployed my Couchbase operator, right? So this is, Kubernetes nomenclature if you guys are more familiar than me. But I've got one deployment, which is my Couchbase operator, and then I can look at the pods as well, right? So I've got 4 pods that are running this Couchbase cluster, including, in addition, the operator that's running on a different pod, okay? So now let's do something interesting, right? So I told you all the cool stuff that our operator can do, and maybe you guys just believe me, but I'm going to try and show you right now, and hopefully it works. So what happens if a node goes down in your Couchbase cluster? Anybody run Couchbase today? Anybody customers? Yeah. Okay. Okay, so what do you do when a Couchbase node goes down today?
It goes down. It goes down. It goes down.
What's that?
If it goes down, it goes down. Somebody has to look and buy it back.
Yeah, what do you do when it goes down? Yeah.
Usually we have a Couchbase support person,
Okay.
group, so usually they deal with that. So.
Right, so he's watching it.
Yeah.
He gets some kind of alert when it goes down. Does he even get an alert? Or you guys,
Yeah,
what's it?
alerts.
Okay, so you've got some kind of monitoring or whatever, but somebody has to be watching that and being aware of it. And then they have to do the steps to kind of deal with that, right? You have to fail the Couchbase node over, right? Or choose to fail it over or do something else, right? Once you fail it over, you have to initiate a rebalance to kick it out of the cluster, right? You have to spin up a new node and VM to run Couchbase. You have to add that to the cluster, and then you have to rebalance again to put that back in the cluster, right? It's a pretty straightforward set of steps, but it's a set of steps that have to be manually done or scripted or something, right? The whole point of the operator is that we do all of those steps for you automatically, right? Okay, so if I take down one of my Kubernetes pods, what I would expect to happen, or what would you guys expect to happen based on what I've told you so far? So let's just kill one of these pods. I'm going to kill this one by deleting it. And what do you think will happen, right? Okay, so that node now is not unresponsive, so he's no longer a part of the cluster, or he's no longer to do any work for the cluster, all right? So he's not taking traffic anymore. And you guys all know by now that if we have automatic failover initiated or turned on, then he will automatically be failed over. The operator has that turned on. Otherwise, this guy's just sitting here, not taking traffic, and you also don't have your data available either, right? Because 1/3 of my data is not available because this node is not responding. I have to fail it over to make its replicas active on another node, right? Okay, so that's something you have to be thinking about if you don't have our operator doing this for you. But the operator will detect that this guy's down. He will fail it over, okay, eventually. Okay, so this takes a little bit of time. Anytime questions while we're waiting for things to get fun. Is there any way to see what the operator is doing right now? That's a good question. I don't know. Is there, to your knowledge, is there any way to inspect sort of what's happening inside the Kubernetes cluster at any given time?
Yes.
Cluster management.
Yeah, you have to. You can see the logs, and there are commands to obtain the logs. And
Okay, hold on. Something fun's happening.
Yeah.
We'll get back to that.
Okay.
Okay, so we've got this node has been failed over. Okay, the one that we took down. He's unresponsive, not taking traffic. Okay, so the operator, based on the definition that we gave it, it knows that we need to have 3 nodes in this cluster, so it's going to maintain that state, right? So it spun up a new VM, okay, added a new pod to the Kubernetes cluster with Couchbase on it, and it took care of adding that to the Couchbase cluster, and eventually it's going to start rebalancing the cluster to get you back to the steady state, right? Okay, so while we wait for the rest of that to happen, you're back on.
Yeah, so the operator is another pod, right? So you can connect to it. You can see the logs. You can see what's going on from that perspective. I mean, it really comes down to the implementation of that particular pod, right?
And that pod itself can go down as well, right? Like
That's
the
correct.
operator goes down.
That's correct. But now at that point, the orchestrator is responsible to
keep him up, right?
To keep it up, right? So at that point, you're relying on Kubernetes orchestrator to bring it back online.
Yeah, and I believe, if I'm not mistaken, you can have replicas of the operator. So I can have multiple pods running the operator. I think that's one of the parameters actually in the definition file. So if I open up operator.yaml, yeah, I can define how many replicas I want of the operator. And I'm just going to logically assume that means I'm going to have multiple pods running the operator for redundancy, right? That's the only thing that would make sense, yeah.
Do the Couchbase containers run as stateful sets?
I don't believe they do anymore. I know in our last implementation, when we were doing the sidecar pattern, that's exactly how we implemented it. I don't think that's the case anymore. I'd have to ask the PM who's responsible for this what's being done today, because this is new as of this week. Actually, I think it's still in beta. They're going to release it GA next month. So this is very new. Okay, he's still healing. He's a slow healer. Okay, I'm using the very cheapest Azure VMs possible to keep costs down. Right, they're one core, and I think like a gig of RAM. So they take a while.
When you just take off one node of the cluster, when you add new one, do you pay more?
Yeah, you don't get VMs for free. I'm pretty sure, right? If I add more Couchbase nodes, my costs go up, right?
Because you said like 4 nodes you charge, yeah?
So
Is it related or
yeah.
is it different nodes?
No, so it's very important to understand the distinction here. So you have the nodes, which are basically the VMs, and you pay for those, right? Then you have the pods, which you can have as many as you want, and you don't pay for more because you're basically running 4 VMs. But obviously, you won't be able to run efficiently. It's going to reach a point where you have so many pods that you won't be able to fulfill whatever you're trying to do. So you have to scale out the nodes.
Yeah, but it scales out automatically somehow.
Well,
So the question here is when I add nodes to the cluster, does it spin up a new VM or does it just add pods? I'm not sure.
Yeah, so the answer is it will add new pods. You want to add new nodes, you have to do it in the portal, like I showed at the beginning. You have to do it like that. There is auto scaling coming in, but it's not out
Yeah,
yet.
I saw that there. I wasn't sure what it was for, so I wasn't going to talk about it. But yeah, so
So you go to the
so if I go to my resource group, right? Oh, before we do that, it's rebalancing. Okay, so he's fully healed now. I don't know if you guys saw, but as we were talking, you saw the progress bar. So the cluster rebalanced. So we're back to our original state, right? And so that's the operator's job, is to maintain the state that we define through our Couchbase cluster config file, right? So we're back whole. The next interesting thing, we'll get back to that question. The next interesting thing we want to do is see how do we scale the cluster up and how do we scale it down, right? So I want to add more nodes to the cluster. That's very easy and we can automate it. All I have to do is change my config file, my YAML file, and instead of 3 nodes, I'll say 4 nodes, right? And so now I want to add more. Okay, and all I have to do is run Kubernetes control apply and apply the new config file. It will kind of update the configuration inside the cluster and achieve that state. So I'll run that, and we should see, if I run get pods again, we should see that it'll launch another pod eventually to host that 4th node, and then it will spin up Couchbase init, join it to the cluster, and rebalance again.
So to answer that point.
So there's my new pod right there. Okay.
That's right. So that's a container, right? An instance of a container running as a pod, right? But behind the scenes, it's 4 VMs that are hosting that.
So in my case, I think I have 5 actually, because I played around. I think I played around with it. I wasn't sure what it was doing, but so yeah, if I go to resource groups here and I go to my resource group into the cluster, there's a scale tab here, and I can change how many VMs are part of my Kubernetes cluster, right? And so currently I'm running 5, which is interesting. And maybe I think it would be more logical if I just added a VM when I add a new pod, right? Because rarely do I want to add another Couchbase node on the same VM that's already hosting another Couchbase node, right? So if I added VMs to the cluster itself, that would make more sense to me, and that may be a direction they're heading. But that would cost you more money, right? Because now you have a new Azure VM, okay? Okay, so there we go. We have a new node added to a cluster, and he will rebalance himself in eventually.
Yeah, one question I had, in the operator talk, they talked about how usage-based billing is not yet implemented.
Okay.
For the operators, how are you guys doing? How are you guys going to handle billing? Like when people are scaling out all these different containers, is it just based off of the maximum usage for the billing period, or how does that work?
No idea. That would have been a great talk for the operator
So
talk.
from the Azure perspective, right? I don't know about Couchbase, whether there's some licensing based on yeah, I don't know whether there is some licensing or some consumption based on the actual software. But from the Azure perspective, you only pay for the VMs and the storage and the network. That's it. Yeah.
So, but yeah, the Couchbase licensing, I don't know how that's working yet. It may be the case. What we generally do, because this is what we're doing for our managed service offering, is you'll pay for an annual subscription for sort of a prefixed amount of nodes, right? And if what we're doing for the managed service is if you exceed that for periods of time, you just let us know how long that's going to be up, right? And we'll kind of charge you for that time period for the extra capacity, right? Yeah. But it's like an annual subscription for kind of a fixed amount, right? It may be the same case for the Kubernetes. I'm not sure. Yeah. But that's a question for our PM, and I can get the answer for you if you give me your contact, after. Yeah. Yep. But that's the show, folks. Any questions? Any other questions? Yeah.
So, the operator manages. So the operator manages the relationship between Couchbase and Kubernetes. Essentially, it's the mediation between those two. So,
yeah.
How resource intensive is that? Is it getting events from Kubernetes, or is it polling Kubernetes when you have something fail and then she's coming back up? So I'm just curious how much
resource intensive that is. Again, that's another question for the PM. I don't know exactly how it's implemented.
And that's the guy who was in the UK.
Yeah, in the earlier talk.
I don't think it would be terribly resource intensive because it ties directly into the Kubernetes ecosystem.
Right.
It's not really going to have much overhead.
It's using Kubernetes APIs, the operator APIs.
So there are two layers, right? One is so there are two layers, right? One is at the Couchbase level, right? Understanding whether the application is running or not within the pod, because the pod might be active, but maybe for whatever reason, the application is not running, right? So if the operator takes that into account, that's an implementation that depends on the actual, implementation of the Couchbase operator. But once it detects that the pod is down, and in order to bring it back online, it uses the Kubernetes APIs to recover from that instance, right? And then it will do some additional things for the specific implementation of Couchbase,
For what that represents.
But for that, whatever that represents, right? And it comes down to, how they implemented the operator. Right?
In your slide deck, you had Kubernetes and then off to the side for additional processing. Is that where you call one container and when it completes, it steps down? How does that work? So I could launch N containers with a resource that I'm looking for to scale up, and then I'm just curious how that works.
Yeah, so you can, right? You can request Kubernetes to.
No, it's not Kubernetes. I thought you had something on the side.
So what I have was, what I was referring to is the Azure container instances.
Yeah.
And use those as a scalability option for bursting workloads. Obviously, you have to implement that. You have to, have an application that takes advantage of that.
Yeah.
So the application would theoretically, we need to spin up and create those instances on the fly as needed, right? And whatever those instances do, they need to be aware of whatever state or data so they can recover or persist whatever they're doing. So it's an implementation capability, right? That is really up to you. The platform allows you to scale those things up, right? But what you do with that scalability is really up to the application.
So is this I as a developer say I want 1,000 nodes, and then I decide I'm going to reduce it down to, I don't know, 250.
Correct. Right now, yes.
Today.
Today.
Okay, thank you.
What is the difference between the ACI and the AKS as far as scaling? Couldn't you just manage the Kubernetes cluster itself to scale? I don't understand the ACI.
So the ACI piece is a pod. You can think of it as a pod, right? that just runs in a cluster that we share, right?
Okay.
So it's just one, right? Or you can have many of those, right?
Okay.
The AKS is your own cluster
Uh-huh.
where you have control of the nodes, and then you can deploy things into that one.
So
Yeah.
you would basically make an ACI node to handle the configuration changes of the Kubernetes cluster that you have on AKS. Is that what you're meaning?
So ACI is a different offering, right? It's a different, it's the
You're
ability.
saying they connect.
Well, so so the next part of it is that we have a connector
Yeah.
that allows Kubernetes
Yeah.
to think about ACI as another, it has the ability to create pods on ACI,
Okay.
right? So instead of creating pods in the nodes, you have the ability to create pods in ACI. So it's for all intents and
So instead
purposes.
of you managing those ones, it's managed on the shared.
Correct.
cluster. Okay.
Correct.
Got it. Okay.
All right, guys, thank you very much. We're going to break for 15 minutes, and then we'll be rejoining in the main hall for the technical keynote. Thank you, guys. Thank you, Donald. Thank you, Jesus.
Yep.